Hi everyone. I think we can start. So, first, before I begin, how many of you are professional testers, like on a regular basis, testing application or writing automated tests? Okay. And how many of you are using the Microsoft stack, like .NET, C#? Only a few? Okay. Anyway. Okay, so as you probably know, a tool cannot solve the absence of test process. However, when you have the test process in place, the right tool can improve the process even further. So there are many tools in automation frameworks, and the talk will be about that. I'll give you an overview about the different tools and how to choose the best one. So first, a little bit of information about me. For the last 10 years, I was working in the field of automated testing. The automated testing is, when you bring browsers and instead of manual testing, clicking there and automating all of this. For 6 years, I worked as a QA architect in 2 big companies in Bulgaria, and part of my job was to design and write scalable test automation solutions. And part of my job back then was to consult companies regarding their test automation efforts and give talks and lectures about that. And for the last 4 years, I have my own company developing a product, etc. So, what we'll talk about. First, I will give you an explanation what is the difference between a library and a framework and a test automation framework, because during many interviews that I led, many people are confusing and they're thinking that they write their own framework, but they're not. Then we'll talk about the different generation of frameworks. And I will give you explanations and pros and cons of them. Then we'll talk more about the 5th generation of frameworks, or the current new generation of frameworks that appear. And I will try to give you a lot of insights and demos from our own product. And they will be the examples will be in C#. However, I choose examples that can be applicable for any language, and you can get the know-how and implement it yourself if you want, or just get the insights. So let's get started. So first, what is a software library? The software library consists of pre-written code, such as methods, classes, test data, etc. Then you can use this code in your own code without writing it again, right? So the most famous example is the datetime library part of the .NET framework. You just call it and you use it. The software framework is something more abstract and generic. And usually it doesn't feel, if it's not working for you, you can customize it by overriding or changing a bit its behavior. And there are 4 major things that differentiate the software library from the framework. The first one, it's called inversion of control. This is not like inversion of control containers, rather than here the framework is managing the program flow, and when you use a library, you are controlling the program flow. Then the second thing is that the framework provides you a default behavior. The third thing, and maybe the most important part, as you will see later in the examples, is that you're able to customize it and extend it to fit your needs. Because sometimes the default behavior is not working out of the box for the team. You can do that by overriding methods, by using hooks or delegates, etc. And last but not least, you can customize and extend the code, but you cannot change the source code of the framework. This is maybe the most important part, because usually these frameworks, not all of them are open source. Then, what is a test automation framework then? Well, it's essentially, it extends the software framework, so it has all of these leverages. But let me give you an example. I told you a bit what is automated test. Well, instead of firing the browser and clicking there, the automated test usually loads the page, types the username, clicking a button. You can do that for desktop applications, for mobile, for everything. So in web testing, we usually, the most famous library that is de facto the standard is Selenium Webdriver. So in Selenium Webdriver, the most famous pattern that we use is called page object. The page object is a class that we put, you know, how we find the different web elements. For example, by class, by ID, these are locators. And in this page object class, we put all of the actions that we can execute on the page. And later on in the test, we just call the page object instead of, you know, finding the element every time and copy pasting the locators. We do that because, you know, for reusability and maintainability purposes. When the locator is changed or the action, you change it only in one way. So we have these page objects. They are really important, and we put them in one project. Then in another project, we put the tests, so that if you have two websites that share the same pages, we just reference the project and use them. Later on, maybe some of you have heard about BDD, behavior-driven development. I will show you examples in a bit, but this is like a DSL called Gherkin. This is like you write the test using like English language. And then later on, you have this, in order this to work, you have like mapping methods in your classes, which you put in another project. And as you can see, the test automation framework is not about the classes and methods. It's more about how you group them, how you use them, what rules do you follow. So it's something more about guidelines. So let's begin with the generation of frameworks. And just small note, in many books and articles about that, many people use for all these tools the word framework, but as you will see, if you recall the definitions that I told you now, most of these are not actually frameworks, they're just tools and libraries. So let's begin. The first generation are the so-called record and playback. Some people call them linear frameworks. And as mentioned, this is not a framework. It's actually, usually these are UI tools that you have this record button in the right corner. You click it, then you start, for example, doing some actions like typing, clicking, etc., making assertions. It will record the session here. And then using the replay button, it will replay all of the actions. And this is why it's called linear, because it's like it goes one way, and the data is hard-coded. What are the pros and the cons? Well, you can really fast, without any programming knowledge, you can create an automated test. However, the data is hard-coded. It's really hard to I don't know, integrate this in continuous integration and get proper test results, or it's difficult to manage different test environments because of the hard-coded data. So the second generations of frameworks appeared. They are called modular frameworks. They are like an extension to these tools. Most of these open source tools providers, they give the option to export your scripts to programming languages. And later on, you can, you know, in your IDE, change the code a bit and handle the more complex scenarios that you couldn't do before. And another type of second generation framework are the so-called data-driven frameworks. They're still in use, by the way. This is an example from MS test, where you know, this test will be executed for each row in the CSV file or XF file that you are pasting here in the attribute. So for the data-driven tests, the data and the test itself are separated. And these types of frameworks, they help to manage the complexity of combination of data that previously couldn't be solved because of the hard-coded data. So what are the pros and the cons? Well, the tests get much more maintainable because you're now using programming IDE when the scripts are exported. And I forgot to mention, by the way, why do we call them modular frameworks? Because here, For example, imagine that you record how you log in your application. Then you exported it as a module. So one module is responsible for doing one particular action. For example, you have one module, one script for login, one for registration, another for submitting a ticket, another for creating an order. And later on, when you have these modules exported, you can combine them in bigger tests and change the data there. This is why it's called modular framework. So because it's exported to a programming language, it's easier to fix stuff because you can use the, find and replace, at least in Visual Studio or in the Java programming IDEs. However, the abstraction level is low since these are not like extracted in methods, but they're just plain code that you copy paste, and meaning that it's like tedious to fix them in many places. And the data-driven code that I showed you here in the previous slide. What happened? Oh, just a second. And the data-driven code here, it makes the, when you cannot see the test data, it makes the test a little bit unreadable. You don't know what will be executed or not. It's really hard, for example, imagine that in this CSV, you want to debug the 10th test that, with the 10th row of data. It's really annoying because you need to pass the first 9 rows of data. Then appeared the so-called third generation of frameworks called library architecture frameworks. And here we get the modules and put them in methods, and basically we create a library. This is why it's called library architecture, because in a separate project you get these modules and put them in methods. For example, you have a login method, which you can later use, or even page objects. And it's a bit much more maintainable, and I will give you an example. Here, in like 6 years ago, back in Telerik where I worked, we had this shopping cart, and we had to automate it. And first we have one shopping cart, and then appeared 2 new products, and 2 new shopping carts appeared. And as you can guess how our developers created the 2 additional shopping carts, it was like copy-pasting and changing the UI. So only the locators here of the fields were different. And we didn't want to, we had back then like 1,000 UI tests, and we didn't want to just copy-paste them because it's too much work and it will be hard to maintain. So the thing that we did was to use facade design pattern. Basically, we are abstracting the workflow. For example, here, filling the billing information, then submitting coupon, discounts, etc. We are abstracting it here in this method. And all of these page objects here are used as interfaces. So basically, we have just, for each particular shopping cart, we have a different implementation for this interface where only the locators are different. But the workflow is defined only here. So if there is a change in the workflow, we change it only here. And this is how the library architecture helps to, reuse some kind of some of the steps. Another third generation of framework are the so-called key-driven frameworks. The key-driven frameworks are some kind of data-driven frameworks. Basically, in this kind of a table, you mention a description, what you do. Then you mention the action. For each particular action, there is a code behind that knows how to interact with the element here. This is how we find the element on the page or on the screen, etc. And in order this to work, we need to have some kind of a shared repository and this code behind steps. So what are the pros and the cons? Well, the library framework is really great because it's much more maintainable. The problem here is that it's because of the abstraction layer, you need to be familiar with many design patterns. And second, if there is a change in the workflow, for example, in one of the shopping carts, but two others don't, then it gets a bit hard to maintain this kind of an abstraction. So we need to make sure to see up front whether this will happen or not. And the keyword-driven frameworks, like they existed before because many people believe that there will be people that don't understand of code and will write these tests, and then another people who will write this code behind files. But right now, I think most of the QA people that write the tests, they should be programmers too. So many of these are like a deprecated approach of writing. The fourth generation of frameworks are the so-called hybrid frameworks, and they're great because you can integrate them in the context of your team. And as the name suggests, they're like, they're a combination of other frameworks that I previously told you about. For example, you can have a library framework together with a key-driven framework, or later on. For example, another fourth type of generation is the so-called BDD, behavior-driven development, that I told you about. This is the Gherkin language, where it's like a story, Scrum story description. And then in order this to work for each of these sentences, in another file, you have this like mapping method where in these attributes or notations, you put using a regex expression or just a string, how you basically telling the framework how to map your sentence to the code that it should be run. So this is another type of fourth generation of framework, and usually they're much better than key-driven development frameworks because they are more tightly integrated in the programming IDEs. So you can debug it, you can refactor it, etc. It's much better. So yeah, about the hybrid frameworks, they have all the drawbacks of the other and advantages of all other frameworks that they combine. And the good thing is that the BDD, you can bring it on top of other frameworks, like more correct approaches, you can bring the BDD, as I will show you a bit later. A little bit of middle generation of frameworks are the so-called, as mentioned, Selenium Webdriver is de facto right now the industry standard for creating automated web tests. And many people decided, like domain experts, decided to open source some of their core frameworks. Some famous examples are Selenite in Java, Ffmpeg, they have an implementation in Java and C# and I think Python. Tata framework, Objectivity, they're all open source and free. And here you can see, I think this code was part of Selenite. It's a Russian framework. So what are the pros and the cons? It's much better to, instead of writing your own framework, if you're not sure how to do it, it's better to download their source code and just integrate it and improve it, etc. It's like you can get the source code. It's much better. And usually these frameworks, they are bringing, they are handling the synchronization issues like AJAX requests, etc., and waiting for elements out of the box. So they're great. The problem there is that almost all of them, they support only web. If you need a solution for mobile, desktop, or web service testing, you need to write your own thing, like using APM or WinUpDriver. And the another drawback of using these open source tools is that most of them don't have a proper documentation. And if you have an issue, of course, this is part of the deal of the open source. You can submit an issue, but these guys, most of them are doing this in their free time, so you don't know whether they will help or not, or whether they will bring some feature or not. But you can do it yourself. And let's now define what we believe that the new generation of frameworks should have. First, they should be very well documented. This is something missing about all other frameworks and standard tools, etc. They should be fully covered with tests. Even if you get the source code of APM or WebDriver, you will notice that they have very few tests. And this is why these libraries are so buggy. And I believe that these new products, new generation of frameworks should be treated as products and be covered with lots of unit tests, system tests, etc. Then should be entirely coded. I don't believe in this magic record button or AI tool that will write the tests for you in these complex scenarios that we are talking today. Should support cross-technology. As mentioned before, most of the open source tooling right now is supporting web, but I believe that this type of framework should have a unified way of automating web, mobile, desktop, or at least in a similar fashion, as I will show you in a bit. Then should be cross-platform. They're really great tools, but for example, they run only on Mac or only on Windows. Your tool should be able to run the tests on both platforms and give you the possibility to write your own code in your favorite IDE on both platforms. Another interesting part is that up till now, it was about how you write the tests, but actually it's really important when you have, for example, as in our case, 10,000 tests, how do you run them? On a single machine, they will run for 1 day. So you need to be able to run them in parallel or distribute it on many machines in parallel and then bring the results. And then the most important part, if you recall the definition of the framework, they should be able to be, they should allow you to extend them and customize them because the default behavior will not work out of the box for you. So let's begin with the most, demo part that I will show you code. What is the story? The Bellatrix is the framework that our company develops and we use it to automate stuff for our clients. How it began. As mentioned, I worked as a consultant for a couple of years, and many companies wanted from me to write them a framework for them. And when you write a framework, you need later on support it. So I decided that it's too much work to support many frameworks for many clients. So I created one thing, and we started to use it for our clients. So we ended up with a solution that tests web, Android, iOS, desktop, API, load testing, everything in once. And now I will show you how we do it. First, how we bring the cross-platform readiness. Well, before we began, we actually wrote the tool in .NET Core and .NET Standard. And this is how we distribute it. Like now, I will show you part of the ways that we actually distribute the tool. One way for the Windows is that we have like a Windows installer with the UI. However, this is not working for Mac and for Linux. And this is why we use the new .NET Core NuGet installers. What is the NuGet installer? Let me create a folder here. And the way we install the tool is we bring the command line and we just write .NET new and the name of the project that we want to install. In our case, this is bellatrix.web.getting started. And this is all we need. And then, as you can see, the tool is installed in this folder and you can start immediately running the demos. How this works? It's quite easy actually to create such an installer. As you can see, these are actually the real code of our installers. First, you need the folder. Then, since we use NuGet to distribute it, the most important part is this new spec file. In the new spec file, basically, this is like an XML language where you put your metadata. How is the name of the project, the version, description, etc. And maybe the most important part that differentiates of distributing a library and installer is this here, that you need to mention that it's a template. the template is basically the installer. And then you need this content folder where you put basically the files, and then you package this and send it to NuGet.org, and the installer is ready. That's it. As mentioned, a big part of what I believe that the future generation of frameworks should be are that they need to support all these different technologies like web, mobile, desktop, etc. But most importantly, they should be the framework should be designed in a way that the way how you write the test is almost identical. Let me show you. For example, this is a test, how we write, this is a simple web test written in Bellatrix. Here, we have this browser attribute mentioning which browser the framework should use and what should happen in the end of the test. Here we mentioned that we will reuse the browser for each test in this class. However, we can instruct the framework to restart it every time or restart only on failed tests. And another behavior that we have is that you can override the class behavior when you put this attribute on top of the tests. So you can override it only for the test level. And then later on, what you have, you use this element create service class to create the different elements using these locators here, and then you can interact with the elements. And this is the simple web test. Now, here you can see the same test, but for desktop, for like WPA for WinForms application. As you can see, the only difference here is that instead of using the browser attribute, we are using the app attribute, and here we mention the path to our desktop application. And then we have the same app behavior instead of browser behavior, but it's the same meaning, like whether the application will be restarted for each test or whether it will be reused, etc. And then again, you have this element create service to create the elements that you interact on the screen. And then this is the Android. As you can see, instead of app, you have Android or iOS, etc. And then you again have the element create service. The way we designed the framework is that if you learn how to write web tests, then it's quite easy to switch to desktop or mobile when you need it, instead of learning the new syntax, etc. And this is what I believe the new generation of frameworks should allow you to. Then, as mentioned, this framework should be very well documented, but for many of you that have an experience more than a couple of years in the software industry, you know that you spend countless hours teaching your new colleagues how to use your libraries or code, because most of our teams don't have a proper tech documentation, right? So the way we try to solve this is like creating a documentation through code. We call this like projects, starter kits or getting started guides. Actually, we created one using the installer, and I will show you. Here I loaded it in Visual Studio. We have similar guides for web, desktop, API, and the whole idea here is to basically document and give explanations how your library is working. Right here, we have like real tests against a real application that show how this element create service, for example, is working, how it's clicking, etc., and explaining how to use the different parts. And this is happening for all of the features that are available for the web module. We will have the same for the desktop. And even we have, after you finish this, going on debugging, etc., you have these to-do files where you have exercises that you can try on yourself to learn it. And this is our approach of allowing our colleagues to learn by themselves instead of you know, repeating and explaining everything from the beginning. Another big part of the test automation frameworks is, as mentioned, many of these tools up till now, they help you to write the tests, but not to maintain and troubleshoot them. But as you know, many of the tests when, for example, you have 100 tests failing, you need to have the tools to find out whether there is a problem in the test. It's like a not well-written test, or it's a real problem in your product. And in order to do so, this new generation of framework should allow you to, to troubleshoot. So I will show you two features, how they work in our framework. The first one is screenshot on fail. The framework detects whether the test failed or not, and in the end, if this attribute here is here mentioned true, it will generate a full-page screenshot. What is the difference? Usually in these low-level libraries, they will make a screenshot only on the visible part of the screen, like a print screen. But instead, our framework uses a special JavaScript framework to create a full-page screenshot, meaning that you will see the invisible part of the screen where most of the websites, they're like a scroll. So you will see the full page. And now I'll show you how we do that. Here we have this full-page screenshot engine. By the way, don't bother to make screenshots. Most of this stuff that I showed you here, they're it's open source. They're the taught articles, how they work. So you can check them later on in the resources section. So we use here a JavaScript library called HTML to Canvas. And since our framework is made in a way that it's like extendable, allowing people to write plugins and extend the MS test and NUnit frameworks, the test frameworks for .NET, we plugged this engine there, and basically first executes the JavaScript code of this HTML to Canvas library, and then it's basically called this get screenshot function, and it saves the content and it's basically making a screenshot and return it as a 64 string. And then later on, from this base 64 string, we use streams to create an image, and we return the image and save it to a file. This is how we do it. Another thing that we do is that we use the same approach, but making video recordings and save it only if the test failed. But how you make video recordings on multiple platforms? You will find that it's really challenging. Like in my previous company, we made this work only for Windows, but we couldn't make it for Linux. And the way we do it, now I will show you the code again. It's actually we use another tool. I will show you the engine. We use a tool called Ffmpeg. It's a console-based video recorder, and it's cross-platform, meaning that we basically call it from C#, the process of this command line. We do that through this get process start info, etc. And the most important part here is that we use to detect whether what is the platform, and we provide different, as you can see here, command line attributes. Like there are different type of recorders for the different platforms. And the another difference is that we need to make sure that the proper file extension is in place, because it's different on the different platforms. But this is how we do the cross-platform video recording. Again, this is open source, so you can get it if you want. So another big part is the customization. And I will show you another feature that we implemented. As mentioned, many people need to be able to create plugins. So another type of plugin that we created is, when you execute the test and when, for example, type or click, the framework, the thing that it's doing, it's making a yellow rectangle so that you can easily find out what it's doing on the video or on the screenshot. And the way we do it is that we basically created a plugin for where you can plug your own code when the element is found. And here, this is the highlight plugin where we just call the highlight function. And the basic way how the highlight function is working is that first we check whether we are executing in a normal browser or in headless, because when you execute in headless mode, you don't need to, making rectangles because you won't see anything. And then we use JavaScript. So first we get the original background of the element, and then we change it for a couple of milliseconds to yellow, and then we are triggering another process that counts, for example, a couple of milliseconds and returning back to the previous value. This is how it works. We don't have time? Or we have? I need 2 more minutes. So, another thing that we do is that it's important for people to allow to write the tests faster. And as mentioned, one of the most important design patterns is the page object. But instead of, like, for example, when you have a team of 20, you need to streamline how people create it instead of writing their own thing. And the way we do it is that we created a plugin for Visual Studio. It's called item templates. For example, when you click here, add new from template, new item, you have these page objects here. And they will be like, for example, here, I can call this login page. And the framework will generate for me these 3 files automatically with some pre-written code. And the way you can do it yourself for your own like design patterns, etc., is quite easy actually. You can go to project, then go to export template. Okay, export template. Then click item template, choose the project, choose the file that you want to be included, click next, add some metadata, and voila, you have the item template, and then it will appear in the right, in the menu. And one last thing. Another thing, as you can see here, is called snippet. The snippet is like a shortcut for generating code. We created such kind of snippets for generating the, like how we find elements. For example, you have V button for generating a button, V anchor for generating an anchor, etc. And the developers in my past company, they use similar things for generating other things, like code of unit tests, etc. And the way you can do it is actually, the snippet is basically an XML file. Last example, I promise. Here is the snippet. It's basically an XML file that it's called code snippet here. You name the title, the shortcut, and then the code is placed here in this C data. This is it. Then you place it in the Visual Studio folder and you have a snippet, which is quite nice to write faster code. So let's wrap up. I told you the differences between a library and a framework. Then we talked about the different generations so that you can pick one very carefully based on the pros and the cons. We defined some of the core features of the new generation of frameworks. I gave you some demos. And you can get like some insights in our documentation about different features that you can implement yourself. On my blog, automatetheplanet.com, you can find all of these examples and more, much more, with open source, and get the source code and play with it with all of the explanations. And many of the things like snippets, extensions, etc. about the Visual Studio installers, you can find on MSDN, the official Microsoft documentation. Thank you. If you have questions, I guess I can answer, or maybe later. Do we have time?
During test automation, there's a big problem with the legacy code. And do you have, in Bellatrix, do you have any solutions to cope with legacy codes differently than other generations?
I didn't quite understand the question about the legacy code. For example, if you have a web application that it's like legacy for 10 years, it's no problem because these are UI tests, you know. You're not writing unit or integration tests. It's basically testing the UI, so you can automate any kind of legacy technology, like 10 versions of Java before, etc. It will work.
Okay.
Does Bellatrix cover like load testing and that kind of stress testing as well, or is it just mostly on the web automation or desktop automation?
Actually, we introduced some wall testing module, and the way it's more of a new way. For example, you can reuse the Bellatrix web tests, and when you turn the wall testing module, it will record all of the requests during the execution, the new execution, and then later on, when you have a wall test mentioning which test you want to include in the wall test, it will reuse the recordings. And it's much better approach than just recording and playback because of the changes. Many times these types of tests are quite useless, and this is how we solve the problem. Okay. But basically, this is working for web now because.
Okay, thank you.
Other questions? Okay, I'll be around for 15 minutes up front, then I'll go to sleep because I didn't sleep at all. So you can find me and we can talk if you want. Thank you.
Thank you, Anton, for the great session. And we would like to have your feedback for this session as well. Use our DevDay mobile app in order to give your feedback. Thank you.